Hey, welcome back. Hey, and thank you for coming back. Shows me you care about your knowledge, trying to get better at everything we do. We have to keep practicing over and over, right? We don't get excellent. We don't build our skills overnight. All right. Hey, listen, I wanted to real quick show you this. Some of my students were having problems with this, and I said, hey, if they're having problems with this, I bet you a lot of people out there are having problems too. So what we want to do today is be able to find the intersections of a system of quadratic equations. For you to be able to do this, you should know how to find the x-intercepts, right? Which means you know how to factor a quadratic, whether it's using the diamond problems, using, you set it equal to 0 and so forth, or using the quadratic equation. Know how to find know how to find the x-intercepts. Otherwise, this is going to be over your head. So if you don't know how to do that yet, go ahead and click that link up there. Watch that video first on how to factor a quadratic and find the intercepts, and then come back and watch this one. All right, so that this one makes sense, and then you can build on your knowledge. All right, let's get to it. Have your notebook out, copy this system right here, and let's get to it. All right, the reason I said you need to be able to find the x-intercepts is because that's the route we're going to go first. But first, because it is a system, this is a system. I'm not going to solve them individually. This is a system. So what I'm going to do, I could see if I could eliminate them or a substitution. But it looks like kind of substitution, but I'm going to set them equal to each other. That's what I'm going to do. So let's get to it. Let me get a pencil here. Let's see, a colorful one. They don't have a nice shade of green. All right. Actually, I kind of like this one. So let's see if I can use this green. All right. Let's see. I'm going to set them equal to each other. So let's go right here. What if I scroll up? No, you can't see that, right? You know, I wish it didn't scroll up in sections. Give me a second. I know it feels like I'm all over the place. Come on, please. There you go. Good job. Okay. Here we go. All right. We have x squared minus 2x plus 4. Right? That's the first equation up here. And I'm going to set it equal to the second one, which is x minus 1. Now, the first thing I'm going to do is just combine like terms. So let's do that. For that, we need a different color. So I'm going to combine this. So let's subtract the x from here, subtract the x from here. All right? That'll be our first step. Notice I didn't do anything with the x squared, so that stays the same. This minus 2x minus x becomes a negative 3x. And then I still have my 4 equals negative 1. All right. Next, I got to get this 1 out of here because I want the equation to equal 0. That's why I'm getting everything over to the other side. So for this, I must use a different color. All right. Plus 1 and plus 1. So right here, what do I have left? I have x squared minus 3x. 4 plus 1 is 5, so I have a positive 5. And on this side, this canceled out, giving me a 0. Right? Exactly what I wanted. All right. Let's move on to the next step, which is I like to use what I call it a diamond problem, because in my class I teach them how to solve diamond problems, but it may be called something else. So here we go. What I want to do is I want to multiply this times the 5, and that goes on top. Well, this is a 1. 1 times 5 is 5. So there we go. This is a negative 3, and that goes right here. So let's put it in there. Negative 3. All right. Now, at this point, I need to find two numbers that I can multiply to equal 5, but at the same time, I need to be able to add them to equal negative 3. Well, my factors of 5 are 5 times 1. And if I add those two, it equals 6. If I made one of them negative, it would equal 4, or it would equal negative. Negative 4. So it's not going to work. I cannot make it equal 3. So the question is, what do I do now? And I didn't know that this was the first problem, so I apologize for that. But when I cannot do this, if I cannot factor this out, if I cannot find two numbers that I can multiply to equal 5 and add up to -3, this means that the graphs here, the graphs created by this equation and this equation, will never intersect. So this would be no solution. No solution. Okay? They're not going to intersect, whatever these are. This is a problem. It's a positive one. So it's probably going to look something like this. And then this is an x minus 1. This is linear, right? Starting at -1. So it's going, if let's just say it's not, because that's a 4. But let's just say that my graph was something like this, right? That means that this linear one is going to be somewhere going up like this, going through -1. So they won't cross. Okay, that's what it means to have no solution, that these two graphs will never cross. All right, I should have made that one my second one. All right, but don't worry. I got another one here for you. All right, sorry about that. So here, hey, what's happening? Okay, it wasn't moving. All right, here we go. So on this next one, let's go ahead and set them equal to each other. Yeah, I could probably use the elimination method, but I'm just so used to setting them equal to each other, so let's do it. 2x minus 3 is equal to x squared minus 2x minus 3. By now you should know it doesn't matter which one you put which. These could be flip-flopped, whatever. It doesn't matter. All right, let's proceed to combine line terms. So let's do a minus 2x on both sides. This right here is going to give me 0. I have -3 equal to x squared minus 4x minus 3. Now, let's go ahead and get this 3 out of here so that we can set the equation equal to 0. And that would be plus 3 on both sides. And that equals 0 equals x squared minus 4x. But look at this. This equals 0 as well. I didn't expect that. I didn't expect that, to be honest with you. Okay, so I guess I should solve these beforehand before I start doing them. But hey, it doesn't matter. We experience this together, right? So that way you can see what I'm thinking and what do I do next. All right, so let's go to it and let's do this. We're going to go ahead and factor it. Now this would be the 1 times my c value, my constant. Well, that's nothing. That's going to be 0. Yeah, 1 times 0, because there's nothing. Okay, you can tell this is unusual, and I don't do these often, so we kind of forget. All right, the b value is easy because that's -4, and that just goes there. So again, this value here in front of the x squared is 1, and we multiply times the c here, which is 0. Because remember, this is my a, this is my b, and this is my c. There's nothing here, so that equals 0. That's why I put it up there. All right, -4. All right, the question is, what two numbers can I multiply to equal 0 but add up to -4? That's pretty simple. That would be -4 times 0. -4 times 0 equals 0. -4 plus 0 equals -4. Okay, that seems easy. Notice how this is different, but I still follow the process, follow the rules. All right, keep going through it. So at this point, what I have here, this -4 right here would be x minus 4. And my other one doesn't make sense because it would be, well, yeah, x minus 0. Right? Now, you set each one of these equal to 0, and you get x equal to 4, and this other one is x equal to 0. And no, that is not a -0, so there's no positive or -0, it's just 0, right? All right, what I have found is technically my x-intercepts. These graphs are going to cross at 4, 0 and at 0, 0. So wow, it looks like it goes to the origin. All right, not a problem. Okay, so now what I'm going to do is I'm going to take each one of these values and I'm going to go back to my original equation and I'm going to choose one of them to plug it into. Always choose the easiest one. So the first value is 4, so let's plug in 4 to this bottom one, all right? That's 2x minus 3. Let's do it right here. 2x, instead of x, put in the 4 value, minus 3. Remember, we got the 4 from here, x equals 4. So that equals 8 minus 3, which is 5. This is my y value. My y value for this order pair, 5. So I found one intersection where the graphs cross. Let's find the other one by putting in a 0. 2 times 0 minus 3. This equals 0. So my y value equals negative 3. So go ahead here and put negative 3. And those are my two intersections of where this graph or these two graphs cross, right? Because if you look at the two equations, this one is linear, this one is a straight line, and this one is the parabola. It creates that U. So it touches at two places. And if it's touching at two places, what I'm thinking, since they're both positive, it probably goes something like this, and there's probably a line that goes something like this. This is what the graph will look like if I actually took the time to graph them. But this is how you find the intersections without having to graph the equations. All right? I hope you got a better understanding of this, all right? And if you did, please hit the like and subscribe button, all right? And stay tuned. But remember, do not skip. Do not try to learn this before learning how to factor. Go back and watch those videos. I had the link there. Maybe I'll pop it up there again, all right? You take care, and I'll see you next time on Math Quest. Goodbye.